Hi guys, hope everyone's doing well. I will be doing the 1.1 number 2 for the problem discussions for week 2. Um, I'd also like to apologize for it being late. I totally blanked on this assignment. But the problem that we're dealing with here is they want us to determine the moments of inertia of these two axes. There's this axis u, this axis v, so you want to determine the moment of inertia along these two axes, and then also to find the product of inertia along these two axes. And so some stuff that are given, they give us the angle here, which is 45 degrees. They of course give us all the physical dimensions. The units are in inches, and based off of the cross sections, we know that we're dealing with rectangles, so we could use the formula for the moment of inertia of a rectangle, which is 1 over 12 base times height cubed. And since the centroids are offset, you would use the parallel axis theorem to compensate for that. So here, the plan that I wrote down was add up all the moments of inertia for the respective axes to find I, U, and IV. So we would first need to find the moment of inertias. I probably should have wrote this down, but we should first find the moment of inertia along the y and x axis, which is actually what I do here. So we use the formula for the moment of inertia of a rectangle first, then we use the parallel axis theorem. The y squared here is, or sorry, I should say the dy squared here is actually the distance between the center of it's really the centroid, the distance between the centroid of the rectangle and the axis. So for example, and I've labeled each of these rectangles. So this is number 1, number 2, just so we know which ones we can refer to. So in this case, the dy squared is 1 squared because it's the distance from the x-axis. So this should either be dy squared or dx squared. But anyways, from here you can see that the whole height of this bottom rectangle here is 2 inches, but from the axis, the x-axis, and the center of this rectangle is 1 inch. It's 1 inch away. So that's what we plugged in here. And then we do the same for the top rectangle here. So plus 1 over 12 times 4, which is the base here of this rectangle, and then times the height, which is 16 cubed, and then plus 4 for the, so we're finding the area, right? So this A is area, so 4 times 16. Same for here, 20 times 2, which is 20 here times 2. And then we do 8 squared because the center of this rectangle is here, and this total length is 16. So 16 divided by 2 is 8, and it's 8 inches away from the x-axis. Or the center of this rectangle is 8 inches away from the x-axis. And then, so that's for the moment of inertia along the x. Now we find the moment of inertia along the y. The y is pretty straightforward. We don't actually have to use the parallel axis theorem because it's along our axis, or the rectangles are along our axis here. So it's not like it's offset. And so we get these two values here. And then they want us to find so a little fast forward, I guess, but to find the moment of inertia along the axis here, u or v, you would use a formula that is it's like a stress rotation equation that you can look up, or I basically just memorize it. It's a couple equations actually. It's this one, and then there's another one actually as well here, and then I think there's one more or two more. But basically, you use these stress rotation equations to determine like the transfer of whatever it is, like stress or the moment of inertia in this case, which we would need because it is a transformation, because we found our moment of inertia for our y and x, but since we want to find it for this v and u, it's like we're rotating with like the axis, so that's why we would use like the rotation equations. But anyways, to find the IU, we would use this specific rotation equation, which the moment of inertia of x and y, or x times y, it's 0 because the y-axis is on the axis of symmetry. So that's why that would actually be 0. And then here we just kind of plug and chug. Here using the formulas, and then we get, so then the formula includes cosine 90 degrees. This one goes to 0 because, again, the IXY, actually, yeah, I calculated here, IXY equals 0, so this whole thing goes to 0. And then the bottom portion here, and also IU and IV are the same because they're parallel. Not parallel, this shape is symmetrical, and the axes are also symmetrical from one another. And then to find this is called the product of inertia. You use another formula, and in this case, this last portion also goes to 0 because of course, the IXY, but also cosine of 90 degrees is also 0. And so yeah, that should be it. Please let me know if you have any questions, and I would also like to get more information on these equations because I don't really remember this in statics, or maybe it was maybe kind of briefly we brushed up on it, but yeah, I would kind of like to know more about these equations and kind of like how to derive them. I know that this is like the moment of inertia of the two bodies plus or divided by 2 to get like the average, and then plus the same thing here. But yeah, I would definitely like to study more up on this. If anyone can maybe link me to the chapter or something. But anyways, thank you for listening. Bye.